Hello, everybody, and welcome to Electricity Canada's Conversation Webinar Series. Electricity Canada is the voice of the electricity industry in Canada. My name is Leah Michalopoulos. I am the Director of Government Relations at Electricity Canada, and I am so pleased to be your host for today's webinar. Before the webinar begins, I would like to take this opportunity to acknowledge that Electricity Canada's office, located in Ottawa, is on the traditional, ancestral, and unceded territory of the Algonquin Anishinaabe peoples. So just quickly, the conversation series features presentations from Electricity Canada's corporate partners, and the series highlights a variety of Canadian and international solutions to current and future challenges faced by the electricity industry. Working with Electricity Canada corporate partners, these webinars have been developed to be of specific interest to those working in the electricity utility space, from generation through to customer. For a list of upcoming webinars, check out Electricity Canada's website at www.electricity.ca. So before we get started, just a few housekeeping items. Our webinar is scheduled to run from 1 p.m. to 2 p.m. Eastern Time. Questions can be asked, and we would encourage that you do so as they come to mind by typing them into the chat function. These will be asked at the end of the presentation. Finally, a brief survey will be sent to webinar participants following the session today. We very much appreciate any candid feedback that you have. With that, I would like to introduce our wonderful presenters today. We are so pleased that experts from Ericsson are here to talk about security challenges and solutions in deploying cellular networks for utilities. This is a timely conversation, as Ericsson is one of the leading providers of information and communications technology to service providers, so they are well suited to lead this presentation today. Presenting from Ericsson are two great speakers. We have Mark Madden, who is the Senior Solutions Director for Utilities North America, and Ken Kaminski, Director of Security for Private Networks. Mark and Ken, thanks again for being here today, and I'll turn it over to you to start the presentation now.
All right, well, thanks, Leah. Much appreciated. Hi, I'm Mark Madden. I've been in this business a long time. I've got 35 some odd years supporting mission-critical communications for real-time applications. The last 16 of which I've been focused specifically on the utility market or utility segment and supporting customers in the utility sector. I've also got some substantial experience with several utilities in North America as a consultant. So one of the things we've done recently at Ericsson was have Zprime conduct a survey about the challenges and utilities might be facing regarding not only network security, but just the implementation of broadband wireless communications to support utility operations. And what I thought I'd do before Ken gets started on the topic at hand is just share some of the results of that Zprime survey. They surveyed over 80 people. Next slide, please, Ken. They interviewed 80 utilities to take an in-depth look at network monitorization and the relative network security infrastructure that would be needed to support it with LTE. They've written a paper on that that's available on our website at the URL below. So get your screen capture out, grab that URL, and go take a look at the paper from Zprime on that. And I think it'll be, it's somewhat insightful. There are some things that are covered in it that I'm not going to go through here today, but they'll be of interest to you. It's interesting in that survey, it was kind of a mix of different types of utilities. So without getting into too many details on the exact numbers of that 80, some 39, 40% were investor-owned or large utilities, for example, in Canada, such as the Crown Corps in Canada, as well as a number of smaller players, some cooperatives and municipal utilities, all in the mix of that. So you're going to see some interesting results from that. Depends on the type of utility, how they're really looking at it. But provides a good basis for understanding where we are today and how to move forward. So if we get to the next slide, please. So one of the first questions was, is your organization planning to use LTE or new radio 5G networks? And over the majority are saying no at this point, but also remember that many of those are small munis and co-ops. So it's not the kind of thing that you will normally see in a muni and co-op, but some of them are actually looking at that. But of the 36% or so that are planning to implement a 5G network, 9% of those are looking into doing that in the next couple of years. We have several that are already in motion. There's a small handful of IOUs in North America that have implemented LTE already. Another small handful that are planning to do that sometime this year or early next year. So there's motion in this direction, and it's important to look at what that's going to do to your operational security going forward. So if we can move to the next slide, please. So as we are looking at those, what are people really looking to get out of LTE? And overwhelmingly, that's just to improve connectivity. So being able to conduct grid modernization, being able to put things like FLISR out, support smart metering, to support distribution automation, to support substation automation. Many of these tasks are possible to do today with LTE, which were not possible in the past. The industry's sort of been moving at warp speed here within the range of trying to implement a wireless solution over the old TDM and wired solutions. So one of the key drivers is also just staying up to somewhere approaching the market technology, where the market leading in the utility business is a little misleading. We don't market lead. We don't lead with bleeding edge technologies, but being able to stay current and have technology that we're going to be able to continue to support for the next 10 or 15 years is something that's of great deal of interest. Next slide, please, Ken. So when asked, do you have the tools in your organization to deal with security threats in a cellular network environment? Clear 40% didn't know. And that's concerning. So of those that are trying to implement, they don't know. Another 40%, 39% believe they have those skills. 21% are very clear they don't have the skills necessary to detect and manage security threats to a private cellular network. So this is clearly an area where we are looking to help understanding and provide some of that understanding that's necessary to bring your organization up to speed in this area. Next slide, please, Ken. So as we were looking at those challenges in the organization, one of the concerns is around increasing the number of edge devices. Obviously, if we're attacking grid modernization with the mass deployment of distribution controls or the implementation of dynamic energy resources that really don't exist in great quantities today, that brings a number of endpoints into play that we haven't had to manage the security of in some time. So that is one of the very important things that people are thinking about as they are looking to deploy these edge devices and the supporting network necessary to manage them. There's also a lot of concern about having the internal talent necessary to manage the network security. Again, having to do with a number of devices, not to mention the new technologies that are being brought in. Clearly, cost is a factor, as is lack of access to critical data. And then when you start looking at the cost and the access to data and how much of an investment the company is really wanting to make in terms of network security, we find that those are less challenging, but by the same token, are things to be considered as you're moving forward to deploying these networks. Next slide, please. So also when asked about the potential security infrastructure challenges they might have, they might see in terms of the integration into their existing IT and OT security systems. Obviously, network security and data privacy is at the top. Cost is very high. Regulatory requirements are very high. Organizational structure is very high. Interoperability is very high. We find those are significant concerns, but as you will see as Ken does his talk, most of these are overcomable. All of these are overcomable. It's just a matter of knowing where to turn and how to go forward. Next slide, please. So some of the key findings. 65% of these respondents found that the improved connectivity is the top value that LTE can offer. And when you can get down into the sub 5 millisecond range with an LTE, well, with a 5G network anyway, or even down into the 20 millisecond range with an LTE network, this brings a lot of capability to not only the distribution grid, but also certain parts of the transmission grids as well. And this is recognized in the industry. I've been out talking about LTE for the last 10 years. So it's no surprise to me that this is really what LTE has to offer. It's the improved response time, it's the improved latency over existing technologies, and it's the extra bandwidth and the extra connectivity, number of items you can talk to cost effectively. On the other side of that, 62% of those that are looking at this either don't know or don't believe they have the skills in their organization to protect against cyber threats. So it's kind of I see the light at the end of the tunnel, but I'm scared to go there because I don't know what I don't know yet. So these are the things we're going to attempt to answer in Ken's discussion today and see if we can help the industry move forward. Next slide. We know that cellular networks can provide a great deal of an almost universal connectivity options, so that we aren't building AMI networks, we aren't building FLISR networks, we're not building recloser networks. What we're doing instead is we're providing a universal communication solution that can cover not only what's in the grid today, but also what's coming tomorrow that we may or may not even know yet. And that's the real value that comes from the ultra low latency and the reliable connectivity you can get with a private LTE or 5G network. So it's that new, secure, and efficient and flexible connectivity that will greatly support our challenges and our needs going forward. We don't have to buy 10 networks to do what one network can do today. So with that, I should be turning it over to Ken and talk to you about how to make sure that this is secure for your network.
All right, thanks a lot, Mark. So my name is Ken Kaminski. I am Ericsson's Director of Security for Private Networks for North America. I've actually got a long background also with Cisco Systems, working with a lot of utility companies over the years. So a lot of familiarity really with just how utility networks are put together. So with the introduction of cellular into a utility network, if you are a cyber architect really looking at defending the utility network and implementing the cellular technology there, you really have 3 different security models that you're considering nowadays, and all 3 of these really come into play. For those of you not familiar with the cellular world really follows a standards body called 3GPP. And there are lots of standards there. The ones that actually deal with the security architecture are TS33401, that is for LTE, and then TS33501 is the actual 5G version of the security architecture. The big documents, a lot of information, and a lot of security functionality is actually built into cellular networks. There's also a couple of others. You know, you're all familiar with the NERC SIP requirements there for the bulk electric system. You know, focus there with that. But there's also another one that's been coming up in particular over the last number of years, which is called Zero Trust. And depending on the vertical, some verticals have more penetration with Zero Trust versus others. But this has become front and center as a new security framework to look at when we're actually designing security for our networks. The actual model came from Forrester many years ago. It's enterprise focused. And then NIST standardized that in a document called NIST 800-207 very recently. So if you are an architect, you know, you really have these three in mind as you're actually putting together and designing the security architecture. You know, just thinking at it from a NERC SIP point of view, we have this traditional division between the IT and the OT network that's pretty much universally, you know, deployed with all of these controls out there. So we have a separation of the OT side, you know, generally with next gen firewalls and then VPN technology there. We have this idea within NERC SIP called the electronic security perimeter, where we'll go ahead and place those controls like the firewalls and the VPN. And then we call those, you know, electronic access points or EAPs. This is interesting because it's considered really an older way to do security. It's really a castle and moat way of looking at things, where all of your defenses are primarily north to south on that look there, on that particular architecture. So if I have someone, you know, coming into the network from the IT side, they're going to go through the firewall VPN technology in order to get into different pieces of the OT network. But in this type of a network design, really, the trust is based on your network location. So, you know, where am I coming from? You know, where is the system? Where are my defined electronic security perimeters? Where are they located? And in this environment also, you know, security breaches have often moved from the IT to the OT side. So some infected endpoint, maybe a control system, you know, engineer laptop or something like that gets infected, and then the contagion or the malware may cross in to the OT side of the equation. And in order to really, you know, think about and deal with issues with that old castle and moat way of thinking about things, many years ago, Zero Trust came about. And Zero Trust it's rather interesting. You know, when we ask this question in the Ericsson survey, you know, are utilities prepared to prevent and solve cyber attacks? And we asked a question about implementation of Zero Trust. And we had 63%, you know, still looking into it. So well over half are just kind of considering this newer security model and the ways that they can implement it to make their cybersecurity, you know, stronger. And then they're looking at what are considered kind of subcomponents of Zero Trust in a lot of cases, you know, with software-defined networks, enhanced identity, micro-segmentation, and things like that. And they're kind of looking at bringing those concepts in really kind of piecemeal, you know, those that were actually looking at it. Now, Zero Trust, like I said, it came about Forrester, you know, a guy named John Kindervag came up with this idea many years ago. And one of the basic ideas here, and this actually maps to the reality, you know, of our cyber world and the world we live in more, the Zero Trust architecture does. It assumes that the network is untrusted. So there's no more, you know, security based on your network location. There's an assumption that the network has been penetrated and that you have bad actors, you know, running around. And there's a number of main ideas with this from the network standpoint. I'll give you a few just to give you a kind of an idea of what some of those are. First of all, there's the idea that every device, every user, and every application, so that's every application network flow also, are individually authenticated and authorized per session. So we're looking at these, controls, both on the device, on the user, and then for access into the application to be there. We're looking at encryption, pretty universally used. So we want to encrypt, all transactions and flows. Segmentation is a main idea also within Zero Trust. So we're not just looking at segmentation points like on the electronic security perimeter, maybe coming in from the IT to the OT side. We're looking at driving segmentation and Zero Trust all the way down through the network, both from a micro and a macro perspective. Macro being, the idea of being across, multiple IP subnets, let's say, and then micro being this idea, it all depends on the actual definition here and who you're talking to, but I like to define micro segmentation as controls within an IP subnet also. So in a normal IP subnet, everyone can talk to anyone by default. But if you're doing micro segmentation, then you have additional controls there so that maybe that device that's there on the same subnet cannot talk to another device of another type that's on the same subnet. So these segmentation controls are driven deep into the network. Automation is another key idea because the speed that attackers move into a network and the length of time that they end up staying there makes automation key in terms of just implementing cyber controls across the network. Another idea here is that policies are dynamic and calculated from as many sources of data as possible. And really, what does that mean? One way to think about this is the way that modern network admission control or NAC technology works. So when you're using that maybe from a vendor like Cisco or Forescout or HP, the device connects to the network, and then whether it's allowed to continue on the network depends on a lot of other things than just the authentication of the user and the device. It might be based on, do you have the corporate malware software loaded up there? Is a personal firewall, part of the load there? So it can look at things like software that's loaded up there. It also has a concept of risk based on vulnerability. So, is this running any vulnerable software? And can I mitigate that, before I allow that particular device to connect onto the network? So we're looking at, things beyond just authentication, kind of from a classic standpoint, to a lot of other data points as to whether that user, that device, or that, or that access to that application should be allowed. And then lastly, there's this idea that, all activity is logged and you need complete visibility into all the network flows. So we're logging all the information that we can, and then we've got, visibility into the flows of who's talking to who. The idea being, we can't protect something that we can't see. So this visibility component is really important to a Zero Trust deployment. So those are just some of the main ideas that are part of that. And then kind of one last piece when it comes to Zero Trust is this idea of identity. So we have this idea, and I'm just using a smart grid device here as an example here. That device, we would want to actually, authenticate the device and the application. A lot of the devices don't have users on it, so it might just be the device and the application here. We would want to go ahead and authenticate that to the network, ideally using something strong like PKI, X509 certificates on the device is an ideal way to really look at that. And then that device talks to some application and then stores some data there, either in the data center, or some cloud-based architecture there. And then in the middle of this, we have these two ideas within Zero Trust. We have this idea of a component called a policy decision point. And this might be something like an identity engine that's making that decision as to whether that device should come on the network or not. And then that policy decision point will talk to what in Zero Trust is called a policy enforcement point, or a PEP. And all this is, in most cases from a network standpoint, these are things like firewalls or switches or wireless access points or anything on the network that can basically, say that device is allowed to access the network, is not allowed to access the network, or we're going to allow it with partial access. So there's this idea within Zero Trust of this authentication of the device, the user, the application, talking to something that's making the decision, and then the network is actually enforcing that policy at some point. And the way that most utilities are looking at Zero Trust nowadays is that they're looking at this primarily in terms of unique projects. It's not a big bang type of deployment, where one day, you're on one architecture, the next day you're not. You really deploy this in phases and maybe look at perhaps a smart meter, project to look at, what's available there. And a lot of the vendors in this particular space, I was recently at Distributech, their devices have a lot of really good security mechanisms built into them that can help you implement this security model in a modern utility grid. Now let me just chat for a bit of time about cellular networks. And I'm just going to kind of start with this basic diagram, because what I've noticed is there are a lot of folks that aren't familiar with cellular networks, at a higher level and definitely not at a deeper level in a lot of cases. So over on the left-hand side of the diagram here, we have the actual device. And that device will have a SIM card located within it. And that SIM card is really just a piece of hardware that protects the key, and it's resistant to actually getting that key related to the encryption portion out of that device. And those devices talk over the radio waves to a radio network or a RAN node, radio access node. That terminology in LTE is called an E node B, and that terminology in 5G is called a G node B. 3GPP loves their acronyms, is what you're going to find. So we've got that connection going over the air, connects into that radio gear. That radio gear will then basically turn that signal into IP packets that are going to go out onto a transport network. That transport network in most utilities is often a private MPLS network based on an IP backbone. And that will connect, all of your major sites together. And that is connecting to the third major piece of a cellular network called the core, or the core network. And what the core is made up of is just applications that are running in a modern environment. These are going to be running on a Kubernetes container-based platform. So all of those different applications, they're called network functions, that are doing the various types of processing for signaling and control and management. All of those applications are running basically in Linux containers. So it's a containerized environment, and they're running there. And that can be, in your own data center, that can be kind of on bare metal. In a modern cellular network, this could even be deployed in a cloud-based environment. Now, a couple of things, and I'll come back to this slide in a moment. Let me talk just a little bit more about the actual device itself, because there's a major difference in the way that a cellular provider someone like Rogers or something in Canada looks at a device versus a utility, which is essentially, looking at building out a private cellular network. So like I said, the security is based on a key. That key is in that hardware that you really can't get at. It's very difficult to get into that hardware. In a cellular network, that key is often called K or KI. And that key exists on the device, and then it exists also in the cellular core. And that's used to build out all of the encryption keys that are used for the various pieces of communication that are going to go on between the device and the network. The actual protocol that's used there is a variant of EAP, and that is a protocol that's used often in your enterprise networks. EAP TLS is used for certificate-based authentication. We in 3GPP, we have a variant of this called EAP AKA that's used to do the authentication and to get those keys out to the device. There are controls in place within the network so that you just can't take, if there was a removable SIM card, on a device, and most of them, a lot of them are becoming what are called eSIMs or being built into the device itself. But even if you had an older one and you pulled it out, you can't just grab that and pop it into another device, maybe that you own and you stole and then connect it to the network, because there are controls in place that you can program in a cellular core to basically tie the device ID to the user ID so that it just doesn't allow that to go swapping back and forth. Now, here's the major difference in kind of thinking about it from a utility standpoint and like a Rogers perspective. See, a vendor like Rogers, they really only care about that SIM on the card. They really don't care about the device because they just want you to use their services. So they really only care about the SIM, whereas if you're a utility, you care very much about that device. And that's a different way of thinking, about the device from a security standpoint between a regular mobile network operator and then a private network like on a utility. So the utility, you very much care about that device and you want to have, other security controls on those devices as much as possible. One example of that is, we're all familiar with having what's called MDM or EMM, that's mobile device management, or the more modern term for this is enterprise mobility management. Software on our iPhones or our Androids or our tablets when we're actually using those in a work environment. And that software implements various things like security controls. It allows the enterprise to download applications. There's a lot of functions. And there's different vendors that are out there. There's about 10 or 15 of them out in the market now, including, vendors like Mobile Iron or Citrix, VMware AirWatch, or IBM Mass 360. And we implement these on an enterprise network in order to control these devices. So that's that's one difference between a mobile network operator and a private network. Some other ideas about these security controls that are here. So the 3GPP standards dictate that we actually have both encryption and integrity controls over that radio interface. And these are implemented with very secure AES algorithms, which are, normal algorithms that are widely deployed and standardized out there. So the mobile network has the idea of implementing these on what's called the control plane, which is doing all of your signaling on the radio side, and then on the user plane. So the control plane sets up the user plane connections, and then the user plane is where the device is transmitting all its data over onto the cellular network. So we've got both encryption and integrity. And by the way, that integrity, if you're not familiar with that, what that really means is it's looking to see that every bit that was transmitted over the air was actually received properly on the other end. So it often uses like a hashing algorithm to take a snapshot of that over here, and then it checks it over there to make sure that there was no changing of that data as it transmitted over that medium, whether maliciously or even, from a non-malicious standpoint, maybe something like radio interference. So those controls are there, and they're actually within the 3GPP standards. And then as you're moving, to the other side of the RAN node, we have this idea of going over the transport network and then connecting to a security gateway. And I'm gonna hold off on explaining this in a little bit more depth, but what I will say at this point is that this is going across the transport network, and the main idea as to whether you will put a security gateway there or not is often related to the question of, do you trust your network transport? So if it's all of your transport and you're good with it, then you might not put it there. But if it's going over something that you don't trust, then where maybe someone could get in there and intercept the communications, then that's where you're going to use a security gateway. And those security gateways are just next-gen firewalls that have cellular network feature and functionality built into them. And the normal providers that you're used to in terms of next-gen firewalls are the folks that you would use in this case also. You're just using the cellular software features there on those particular products. Then as you're going over to the right, you're going to want to think about putting a next-gen firewall there in that position as you're going out into your network, your normal interior network. And that will just be your regular next-gen firewall vendor, in most cases. And that interface there is called the SGI interface in 4G or the N6 interface in 5G. Again, you'll find 3GPP loves their terms. They define everything and label every interface that's out there. So let me just chat a little bit more about some of this. This is kind of another look at the interior of a cellular network. And we're crossing, the private transport network. And a couple of things that I want to point out here is really the logging and the telemetry and how that flows in this type of an environment. So over in your upper right, you'll see the SEM, Security Information Event Management platform, often in the utility space, that's Splunk or IBM. So we're going to eventually want the logs to go up to that in order to for them to take a look at it. But here's where you have a difference between cellular networks that's different from regular IT, is that the existing SEM platforms that are out there, like your Splunks and your IBMs, primarily are geared towards IT networks. They don't have a lot of the features that are, unique to cellular networks. And in order to plug that particular gap, in Ericsson, we have this product called the Ericsson Security Manager. And that particular, product is made to do a number of security functions, including processing those logs for things like false base stations, for example. And then looking at those logs from that standpoint, and then forwarding all the logs on to the SEM in the SOC after that point. There's also a full PKI that's generally built into the cellular network infrastructure to control all of the maintenance connections that are actually going to all the different pieces of gear and all the different areas here, and then to be used for secure communications. Just a little bit more on the Ericsson Security Manager. It's actually designed to do two main security functions. You kind of think about it as a high level. Now, one of those functions is what I was talking about earlier in terms of managing logs, telemetry, and then looking at use cases that are based on, looking for threats that are coming in. So detection of false base stations is one of the features that it does. All of those logs would go to it, and then it would actually process it. Some other examples that we have coming up are detection of DOS attacks on the transport network and some endpoint security integration mechanisms also. Another thing that it actually does is, and by the way, that can help in terms of SIP with SIP 007 for the system security management, requirements that are there. Another thing that it actually does is it manages and automates the security configuration compliance. Basically builds a baseline, and it monitors all of the devices in the cellular network to make sure that they have the proper security configuration. And if anything changes, it will automatically reconfigure that device, whether it's on the radio network or the core or wherever it is, in order to make sure that the security configuration is maintained. And SIP 10 actually has requirements to do that. A lot of times that's done manually in a lot of utilities, but something like this could actually automate that, so it could free up security staff to do other things, for instance. Now let's kind of look a little bit deeper, at the SEG and the transport network and really what's going on here. Now again, whether you'd actually have a SEG or that next-gen firewall in front of the core is again dependent on whether you trust your network or not. So if it's untrusted, you see the bottom kind of orange cloud there. That's where you'd have the SEG. If it's trusted backhaul, then those connections can just connect directly into the router that's front-ending the core, which again are just the applications running in that Kubernetes containerized environment that's actually running the cellular network. Now, if you think about how we design these networks and what's recommended, one of the things that we recommend highly is that the OAM network is completely separated from the user and the control plane. So that, and you'll maintain that separation also over even your untrusted net or your trusted network, I'm sorry. You'll maintain that over that environment also. So you've got a number of things that are occurring here. You've got segmentation, which is happening on the untrusted and the trusted side. That's usually done by using things like virtual routers or VRFs on the RAN gear, which connects into, on the MPLS network, something like an MPLS VPN component that's there. A lot of the vendors that are in this space even have their proprietary ways to do this, and you could hook into that proprietary mechanism. So there'll be one for the OAM segment, there'll be another one, for the actual production or the RAN traffic, and those will connect in to those areas on the MPLS side. And then those will break out into different areas on the actual core. And then if we're running the security gateway or the SEG, then we're going to add encryption and integrity to that, and we're going to use the standard IPsec protocols in order to do that. And then if you do put a SEG there, this is another major difference between a mobile network operator and a private network. If you did decide to put a SEG there, in order to deal with this untrusted portion of your transport network, in a lot of cases, you want to have some control over those endpoint devices. So you're going to put some higher layer 7 next-gen firewall features onto that particular next-gen firewall in order to deal with things, maybe like anti-malware control or next-gen IPS or something like that. On the OAM network, keep in mind this is meant to be completely separated on your RAN and going across your transport. There are a lot of mechanisms that we build into these in order to provide, additional security. So we generally will build some type of a centralized authentication and authorization type of network there in order to connect into. Something like an LDAP, a central LDAP store, or Active Directory is very often used, where all of the users are located there, and then each individual user on the network has RBAC or role-based user controls, so that what the user is allowed to do is unique to that specific user. Everything is based on PKI-based certificates, so it's very secure connecting into all of these devices, and then only encrypted communications protocols are actually used. Things like netconf using TLS or SSH, SNMP version 3, and then secure FTP. So no unsecure protocols are used for the actual OAM portion of the network. And then everything is also logged. Now I'm going to give an example here is just the Juniper SRX as an example of that next-gen firewall where we could use as the SEG, or also as that firewall that goes out into and connects to the rest of your enterprise network on the other side of the core. Palo Alto, by the way, very strong in the enterprise space. They fully support all of these features. So, everything that I'm talking about here from a Juniper SRX standpoint, you can just think about Palo Alto. And I know that a lot of the other vendors also support similar features on their firewalls. But you generally are looking at, deploying these. They're often deployed in front of the actual core as a physical firewall, but you could deploy virtual firewalls also. I mentioned earlier that, these are really the same next-gen firewall vendors that you're used to dealing with, but they have some unique features that have been developed over the years for the actual cellular network. And as an example of this is they have a protocol support in order to implement firewalling. This is usually built into the basic firewall feature set portion, of the actual next-gen firewall products. But one of the main differences in a regular IP network that you're used to operating in a cellular network are the layer 4 protocols that are used, because they're different in a cellular network. And they're different. We've got different protocols that will run here. One of them on the control plane, which is SRTP, and then on the user plane where the user traffic is flowing, there's a protocol called GTP, and that stands for GPRS Tunneling Protocol. And again, these are layer 4. So what are they? Well, at a very high level, SCTP, this is running on the control plane, and it's used instead of TCP, which we're used to, because it adds a lot more availability features than TCP gives, so that we can get a lot more control and higher availability levels than we can on a TCP network. So that's one of the main differences there with that versus TCP. On the user plane side, the GTP protocol is basically built to tunnel the traffic from the RAN through the transport network to that point where that firewall drops it out onto the enterprise network going out the other side. And basically, this allows the IP address to come from all the way on that side of the network. And then everything just gets tunneled from that endpoint all the way to that point, and then it gets dropped out the enterprise network on the other side. And again, these are layer 4 protocols, and these firewalls have lots of features that help, they understand these protocols, and they can do a lot of kind of advanced things in terms of firewalling them. And then, you're going to think about, as a private network, maybe you want to run some of these higher level layer 7 functions on some of these firewalls. The mobile network operators don't tend to do this, but as a private network, you may. So things like application visibility and control, intrusion prevention, anti-malware, these are things that you might want to think about running on these firewalls on the cellular network that are connected there. A couple of things about the core. And again, remember, what is the core? It's just where all of these network functions that are controlling the network are running. There are a good number of them in a cellular network. They all have different things that they do. And there's a change between 4G and 5G from a security standpoint. 3GPP really added a lot more security into the native 5G core than existed on the 4G side. So the 4G really assumes that this is a secure location that the core is located in. And one of the main protocols that's used inside the core for these various applications to talk to one another is a protocol called diameter. And really that protocol is just a variant of radius. And we're familiar with radius on the enterprise side. It's just a variant of that. And it's used in order to do a lot of these control functions within the core itself. In a 4G core, all of those different network functions talk to each other generally over a completely unencrypted environment. So they're not encrypting anything. They're not authenticating one another. This changed with 5G. So what 5G said is, hey, let's add some of those zero trust type of principles, into this type of an environment here. And what they actually do is there is this network function called the NRF. And what that NRF does, that's network resource function. Think about it as the traffic cop. So if I'm a function, maybe doing a signaling function, and I want to talk to another one, maybe to get some information, what I do is I ask the NRF for permission to talk to that other function. And that permission is then granted in form of JSON web tokens. And it uses just the standard OAuth 2.0 based authorization scheme that's been used in web environments, for a long time. All of these calls that go back and forth, by the way, it's very different from the old diameter-based way that was used over in 4G. We're using all HTTP2 calls based on REST APIs, so very familiar, type of technology for you on the enterprise. So these are all REST API calls that are going back and forth. They're getting these OAuth 2.0 authorization tokens, and then they're using TLS encryption using PKI certificates to do that. So it's a lot more secure, just from the standpoint of, communications even within the core. And, at a very high level, these are really, taking some zero trust based principles and then integrating those into the actual 5G core in order to make it a more secure environment versus the older 4G technology. There's another piece of this too. It's basically dealing with the roaming connection. And roaming is very different in a mobile network operator environment versus a private network. So this is the connection that connects out to the outside world. A mobile network operator is going to be talking to a lot of other operators across that interface that's there, versus most of your private networks are generally just talking to one mobile network operator that you've partnered with. So there'll only be one connection here. And at the edge of this connection here is a network function that is a little bit different in the 4G world versus the 5G world. And think of this as basically software that's running some advanced firewalling functionality that understands the diameter protocol if I'm operating in 4G. And that device there would be the diameter edge agent, or the DEA there. That's going to filter all these connections as they're going out between that roaming partner that you're talking to. And then in a 5G world, we're using a piece of software called the SEP, which is a security edge proxy, which is doing a similar thing just for a 5G network. And this is doing, it really understands these protocols. It's looking for things like location fraud, unlawful location tracking. So think about it as a kind of a firewall, you know, embedded within the software that's just doing some advanced security functions here. Within the Ericsson product portfolio, we call this the Unified Signaling Firewall, and it has these embedded functions. And then last point here.
This is Leah. Just you have we have 5 minutes left for the presentation. So just
I do.
a time
Yeah.
check.
Yep, absolutely. This was my last slide, and what the very quick point on this is that a lot of times people want to tap the core in order to look at the information going back and forth in terms of things like using like NetScout probes or other vendors in order to get information out of this. This is a very different in a modern environment where, again, it runs in a Kubernetes container-based architecture, and trying to get that information off like a virtual tap is very difficult to near impossible in an environment like this, because you could have containers spinning up on multiple pieces of hardware all across that, and trying to grab that information is hard. So what Ericsson did is we implemented a software probe in order to do this function. So the probe-based functionality is actually built into the application container-based architecture, where we will take these packets, construct them, and send them over to a vendor like NetScout. So it's just something to keep in mind. It's a very different environment. And with that, I'll pause here. And are there any questions?
Any questions in the chat, but maybe I will, since we only have 4 minutes left, maybe I'll ask sort of a concluding question for you. You gave so much great information today, but if you would sort of hope that the listeners here today would take away sort of one main thing, one or two, what would that be?
Cellular networks are here to stay in the utility space. They really provide a very valuable function. And there are many mechanisms that have been built in by 3GPP to secure those networks. And we can combine those with some of the other enterprise tools that you've got in order to provide a very secure solution.
That's great. Well, I think with that, we are at just about 2 p.m. So I think we should close off the webinar for now. But Mark and Ken, thank you so much for joining us all here today. That was some really interesting stuff, some really great work that Ericsson is doing and finding solutions to some tough problems out there. So we're really glad you're able to be here with us. So thank you. And with that, for everybody else, thank you all for all our participants for listening in. And please keep an eye out for future webinars and events through Electricity Canada's monthly newsletter, Current Affairs. We're happy to sign you up to that if you are not. And just thanks so much, everybody, for being here today, and have a great rest of your day.
Thank you, folks. Thank you, Leah.
Thank you.